Hello, sir. There's no sound. Or is it just me?
Um, yeah, my mic is on, so I'm not sure why there's no sound.
So now we can hear you.
Okay. I don't know why team always want me to change the mic first before it can work. Can you guys see my screen at least?
Yes, sir.
Yes, sir.
All right. Is there anyone who still have to write the big data exam?
Yes, sir.
Yes.
Okay. I hope you got a feedback from those who wrote it already.
So, sir, it seems that it's much harder than the mock exam.
Yeah, of course.
Mm.
Yeah, that's what I mentioned. It's the main exam is a bit harder, but um, you need to understand something about these exams. Um, you can't rely on your memory only. You need to rely on your understanding. That's why we say you need to attend classes and ask questions. As we're moving along on each chapters, you need to ask questions because the more question you ask, the more understanding you have. And when you get in the exam, when you look at the question, you know exactly uh, what they're talking about. Because you know what they're talking about, it's easy for you to find the right answers. Because if you think that you're going to just prepare the exam 2 days before the exam and memorize things, it doesn't work like that. Because no matter how good your memory is, the questions are tricky. Sometimes you have, it's all multiple choice. There's no, and then there's just a few questions sometimes that require you to fill up certain uh, to fill up certain blank parts, yes. But most of the questions are multiple choice. And sometimes the answers look similar. So if you don't have an understanding of that part of the course, it becomes a bit difficult. It becomes a bit tricky. But if you ask questions as we're moving and then you have an understanding, everything becomes easy. Everything becomes easy. Right? Because there's a lot of theories. If you think you're going to memorize everything, it's not going to be that easy. So you need to note that. But if it didn't go well for you for big data, no problem. You still have AI and cloud computing. So you just have to change your strategy this time. Prepare it properly. Yeah. All right. Okay. So any question before we could continue? Okay, so we went through different. We went through mostly Mindspo so far in terms of the AI development framework. Remember, what is an AI development framework? It's just a piece of software. It's a software and environment that can help us build machine learning models. So that can help us build models without having to really go into details in the algorithm. So that becomes a bit easier. So we spoke about PyTorch, TensorFlow, and we'll focus more on Mindspo, which was created by Huawei. And we could see in Mindspo that we have different architecture of Mindspo, but what we understand is that Mindspo is an all scenario framework, which means that you can build your models or deploy them either on devices, on edge, which means on the routers and them, and on cloud. Okay, so now looking at that, we seen that in the architecture of Mindspo, we have different parts of Mindspo that can do different things. You have part of Mindspo that help you with training. You have part of Mindspo that help you with deploying your model. What is deploying a model is publishing your model out there, right, in the real environment. So we've spoken about many methods used in Mindspo, how we're building all this network using Mindspo. And then last time we spoke about the heterogeneous parallel training, which means when we're training a model, we divide the neural network into multiple multiple graphs. So certain part of the network are going to use as the hardware, they're going to use maybe an Ascent processor. The other part will use maybe a CPU, right? Okay, and then we mentioned how, in terms of deployment, if you want to deploy it in the real environment there, you can either deploy it on the cloud or deploy it on the device. And if you deploy it on a device, that means you are deploying it offline. We use Mindspo Lite. But if you're deploying it on cloud, we use Mindspo Serving. Okay, so and then the last thing we spoke about was Mind Insight, right? So what did we say about Mind Insight? Mind Insight was just kind of a visual representation of what you are doing. So basically, it's the visualization and just a toolkit to visualize everything that you are doing with your neural network from the time you are training it to see how it's performing, you know, to just have a tap of images that show you how the model is training, when you're debugging it, how it's analyzing, and to see the performance of your optimizers in your deep learning model. Okay, so Mind Insight is just a tool that provides you with a better insight into the training process. Okay, so you can visualize everything such as the loss, the accuracy, the learning rate, and all those things. By the way, when I'm talking about you visualizing the loss, what is a loss? When we talk about machine learning, what is a loss? Can anybody tell us what is a loss? Anyone? Please tell us what is a loss. Anyone? What is a loss? Is there anybody who does not know what is a loss? When you talk about loss in machine learning, this is one of the words that we've used many times. Is there anyone who does not understand what that word means? Right?
I think a loss is the difference between the predicted value and the actual value in machine learning.
Yes, that's the loss. The loss is what, as the word say, the loss. So basically, the difference between the predicted value and the value we're expecting to predict. So basically, what does this mean? It means that if we have 5 pictures of dogs and our program tells us 5 of those pictures are dogs, which means that it's accurately predicted 5 out of 5. There's basically no loss there. But if it only predicts 2 and say there's 2 dogs while there were 5, you can see how big our loss is. So our loss is what is the difference between what it was supposed to predict and what it's predicted. So now when we have such a thing, that's the whole point of machine learning. Machine learning is all about calculating the loss and reducing it. So the more we reduce the loss, the more accurate our model becomes. So this part of Mind's framework, the Mind Insight, will show you can visualize the loss and see the performance of your training, your model in the during the training. Okay, so the next one will be Mind Vision. So what is Mind Vision? So Mind Vision is also another toolkit that comes with Mindspo, right? So this is mostly designed for computer vision. So when we talk about computer vision, we talk about AI or models that deal with images, with videos, you know. So models that deal with things like image classification, for example, classifying between dogs and cats, you know, all those things, object detections, image segmentation. So all those things that has to do with computer vision. So we have Mindspo Vision, which is the specific toolkit that is built on in Mindspo. So it's basically a tool that will help us with computer vision computer vision training, right? So you have all your image classification, image segmentation, dealing with videos, 3D images, you know. So you have all these examples of data, right? So basically, it's kind of a computer vision library, if you can call it that way, right? So it will help you with providing pre-trained model, right? That has to do with computer vision. You have your standard data set here. So your data set can contain some images. Okay, so that's how Mindspo Vision will work. Okay, so the next one will be the Mindspo reinforcement. So Mindspo reinforcement. So what is a Mindspo reinforcement? So this is just another part of this framework, which will support distributed training with agents. Okay, so do you guys remember the three types of learning that you have in machine learning? Can anybody remind us again? The three main types of learning. How will you teach the machine?
Reinforcement learning.
Sorry?
Reinforcement learning.
Yeah, I'm saying the three types.
We have. I think there's an echo.
Yeah, and there was 3 echoes. I don't know.
We have supervised. So I think it's me. So we have supervised, unsupervised, and reinforcement.
Yeah. So basically, we have supervised learning, we have unsupervised learning, and we have reinforcement learning. So what does it mean? It means that when you're training, if you tell the model what type of data it has. So let's say you provide pictures of, you want to create a classification model that can determine between dogs and cats. So when you provide in your data set, when you provide pictures of dogs and pictures of cats, so you are basically, all your data will be labeled. So all your data will be labeled. That means that you will have to tell the machine that this amount of pictures represent cats, this amount of pictures represent dogs. So in that case, you're dealing with supervised learning. Why is it supervised? Because you are telling the machine exactly what you're dealing with. All right. But in an unsupervised learning scenario is when you provide data to the machine, but you do not tell the machine what is this data. So the machine itself will try and classify those data into a certain group based on the similarities between the data. So, and then the third one was the reinforcement learning. Reinforcement learning is where you're teaching the machine, not by providing data, but by creating a reward and punishment system. So you create what we call an agent. So that agent will be put into an environment, and whenever the agent makes a mistake, there is a punishment. And then when it takes a good decision, there is a reward. And what the agent will do is it's going to try and take actions that are accumulating more reward. And that's how it's going to learn from the data, right? So this is how you train self-driving cars and all these models like the robots. So basically a robot that is supposed to be making coffee, for example. So the robots, you let the robot make certain action, you let the robot make mistake and you keep punishing it. So the robot will keep changing. Every time it restarts the action, it's going to change. So if you've played, for example, video games, those adventure games where you get somewhere because you didn't see something and then you get killed, and then the game take you back to the previous level. So now when you come again and you reach that place, you already know what to expect. So you avoid that route. You go another route and then you move to the next step. That's exactly how the model is being trained. So the model go through the data and take certain actions, right? So it takes certain actions and then it get a reward or a punishment. So if it get a reward, it means that that action was good and the model will record that action as a good action. And the next time that the action is going to take. And if the action was accumulated the punishment, then the model is going to understand that that was a punishment, that was a wrong action. All right. So that's how reinforcement learning works. So basically now, when you're using MindSpo as a platform, you have MindSpo reinforcement, which is just a toolkit that will provide algorithm, environment, utilities, and all the APIs that you need to build and train your reinforcement learning model. Okay, so basically, remember now we need an environment. We need to create an environment. We need algorithm, right, and everything that you need, right. So now MindSpo reinforcement will really simplify the process of developing reinforcement learning algorithm. Okay, so it's very easy. There is what you call an environment. You know, like remember in MindSpo we talk about environment. So in an environment, what you call it again? Environment created by OpenAI. It's called Gym, right? So that environment, for example, with MindSpo, you can easily interact with that environment. Okay, and then you can basically monitor and evaluate the agent performance. So when we talk about creating agent in machine learning is you create this AI. So trying to see what example I can give you. What example can I give you? Okay, so let's say I want to create an agent. I want to create a model that will be able to maybe trade on the stock market. So what I will do is, what is the environment? The environment will be the data that I'm going to have. Let's say I have the data for the past 3 months, how a certain stock was behaving for the past 3 months. So now this agent is going to take action. It's either going to buy or sell. And then we're going to calculate how much profit it could have made if it took those decisions. So now, as the model will be learning through the data, it's going to take action one, which is a buy. After it buy, if it loses money, then the model now knows it was a wrong decision. So next time it gets on that day, on those data, it's going to change the action. It's going to take a different action. As we test for maybe 3 months, then we can see which actions were going to take us into profit. And now the model will save that as the right action and create actually a strategy behind it. All right. So that's the thing. So you create an agent, you put it in an environment, and then it learns from the data. Okay, so that's what Mindspore reinforcement will do. So Mindspore reinforcement is just a toolkit that will help us build reinforcement learning models. Okay, and then the next one you have Mindsport Federated. Okay, so basically, what is Mindspore Federated? So this is another toolkit that you have with Mindspore, right? So this one is just designed to kind of deal with the privacy of your machine learning models. If let's say you are using multiple devices, and those multiple devices, or you are sharing the information with many different businesses. So when you have that now, right? So your information are being shared with many servers, right? So when you're building this type of model, so you will need Mindspore Federated, because this is just an encrypted distributed machine learning technology, which will allow different participants to build AI models without sharing local data. So you don't really need to transfer the data, but you can share those data and use them in different locations. So that will be done with Mindspore Federated, right? So you have kind of, when we say we have maybe multiple clients, which means you have multiple devices, right? So multiple devices that will collaborate in terms of training the model, right? So instead of sending just private data to a central server, so the model will just update the different parameters as the information are being shared, right? So basically, when you think about it, you will find there is many companies today that are training the model with the data from people's devices, such as all your chat GPT. If it gives you the wrong information about a certain subject, then you correct. So it's basically learn from your device. You have our cell phones that provide data that some AI tools out there are learning from. So you have all these system out there. Okay, so this is Mindspore Federated. Okay, so and then we also have other components of Mindspore, such as the Mind Quantum. So the Mind Quantum, which is just an open source deep learning framework of Mindspore, right? Which will also support training and inference of multiple quantum neural networks. So this is basically when you have multiple neural networks in different algorithm, different places and all that. And then you have the Mindspore probability, okay, which deal with more with models that has to do with probability calculation and all those things. Okay, so the process of creating this model then after we've done all these type of toolkits that we have in Mindspore. So now to create a model right, on your Mindspo, the steps have become very simple now. So you look at what you need to do. What is your scenario? Remember, we said the 4 elements of AI. You need your scenario, which is the idea that you have. The second element is the data. You will need data. What is data? Is every information, everything that you need to provide to your model so that it can learn from it and provide the best AI tool that you want. You will need the algorithm. What is the algorithm? Is the type of code that you're going to use to create this AI. And then the last one, what is the last one? What did I forget, guys? I mentioned scenario, I mentioned data, I mentioned algorithm. What did I forget?
Computing power.
Yes, computing power. Can you give us an example of a computing power, of something that can be considered as computing power? Can you give us an example of someone that is something that can be considered to be computing power?
Operating system.
Sorry? I didn't hear anything, guys.
A powerful RAM.
Sorry, repeat again.
I would say an 8 gig RAM or a powerful RAM.
Yeah. So and then I heard someone say operating system. Did someone say that? Oh, I didn't hear
Yes.
Okay. Can anybody tell him why an operating system is not part of computing power?
I think because it is a software.
Yeah. So computing power is all the hardware that you basically have. You know, the hard part of the computer that will play into training or in model inference. Okay. So when we talk about computing power, we can involve all the CPU, GPUs. We can involve all the processors that are being used. Okay, so the first step will be you will have to basically set up your environment. So obviously, if you do not have Mindspo, you will need to install Mindspo on your computer. Okay, and prepare the cloud environment if you're going to deploy or train your model through the cloud. Okay, and then after that, you're going to have to do a data preparation. So you will need to find the data. Remember last time we spoke about there is many platform online where you can collect the data from different fields, you know. So if you're looking for data to create a certain model, there's no need for you to start recreating this data. There is open source out there where you can collect the data. So you need to acquire the data, pre-process the data. Remember, when we say pre-process the data, what does it mean? Make sure you have the right data. So if you're trying to create a model to determine between male and female, you have to make sure your data have pictures of male and female. There mustn't be maybe pictures of flowers or things like that that are not related to your scenario. So this is the pre-processing of data. Okay. And then you have to build your neural network. Remember, in the neural network, we have to define our hyperparameters, and then we build the model structure. So I have one question. Why here we define the hyperparameters, we build the model structure, but we do not define the parameters? Can anybody tell us why we do not define the parameters? Why aren't we defining the parameters? We only define the hyperparameters. Anyone tell us? Anyone can tell us? Can anyone tell us
So
why? Yes.
is it because it's not necessary in network building?
No. Anybody else? Why are we only defining hyperparameters? We are not defining parameters.
Is it because hyperparameters, right, are determined by the developer, and then parameters are determined by the AI when it starts?
Perfect. That's the right answer. Because parameters are not set. You don't set the parameters. The parameters are automatically set by the model itself. Those are internal settings that the model will be changing in order to train. So you do not set the parameters. So you only set the hyperparameters. So your hyperparameter, an example of an hyperparameter is how many layers you're going to have in your neural network. That's an example of hyperparameter. How many nodes per layers, all those things, right? So, and then you build your model. So after you built your model, now we need to train. So in terms of training the model, we will train the model. Obviously, after training the model, we show that, okay, the model is trained. When it's done training, we can save the model and then we can test it to see if it's performing well. So if the model is not performing well, then we check where is the problem. Did we get the right data? Do we have our data clean, right? If that is fine, we move to the next part. Is our network done properly? If there's any changes we have to do, we do the changes and then we train the model again. We save the model and then we're going to test the model. And if it passed our testing, whatever we want to achieve, now we can see how we can deploy it into a real environment. Either we want to deploy the model on a cloud or on a device, right? So basically, this is the model that will be used for future prediction. Okay, so guys, if I'm using MindSpo and I'm deploying using, I want to deploy it on my cell phone. I've created this model. I want to use it on my phone. Can anybody tell me what tool of MindSpo am I going to use to deploy it on my phone? What tool of MindSpo am I going to use for deployment of my model on my mobile device? Anyone? Anyone? Guys, this should be easy.
Is it MindSpo Lite?
Perfect. Yeah. MindSpo Lite. So MindSpo Lite is used for deployment on device. If you want to deploy you want to deploy it on the cloud, then you're going to use MindSpo serving. All right. So that's what you're going to use there. And now that I've deployed on my phone, right? Can you give me an example of a computing power that my phone will use to deal with that AI? If I was on my computer, my laptop, I was going to have my GPU, you know. Now on my phone, what do I have that will be able to deal with an AI?
RAM?
Sorry?
RAM.
No, it's something I'm looking for. Which unit? Which processing unit? That's my phone.
Is it the new?
Yeah, look like you're on the right track.
NPU?
Yes, the NPU, neural processing unit. So that's what deal with neural networks on your devices. Okay, so all right, so we've done the whole process. Now we can be able to deploy our model. So when you look at an example of image classification, where we look at these three pictures, they are all flowers, right? But on different pictures, there is other things on the picture, right? So if we looking at something like this, where we say we can determine the category, you know, and like which images represent a flower, which one represents a cat, a dog, or a plane, or anything like that. So this is a classification problem. But because we provide the data to the machine, we're going to call it a supervised learning, because when the machine is learning from the data, and we've already told the machine which data we're dealing with. So that's why the supervised learning, we call it classification problem, because it's about predicting a certain category. All right. So this is an example. What kind of flower is this? So we want to know what kind of flower is this. So the machine needs to be to have been trained with different type of flowers, and the machine knows exactly what type of flowers we're talking about. Okay, so this is an example of an image classification application called the RaceNet 50, which does that. Okay, so this is just an application, an environment, how you set up the environment. So this is how you're going to install your MindSpo. Okay, so and then you set up your cloud environment, data preparation. So in this case, data preparation, when we're trying to train our model to find what type of flowers, so data preparation, in this case, they've used about 633 photos of this type of flowers, the daisy, and then the dandelion, and 898, the roses, you understand? So there's this type. So basically, we've given these files to the, as you can see here. So this is a folder called flower, and then we have all these type of pictures that we give the machine, that the machine will learn from. Then we can do a data pre-processing, which means we can read the data set, define parameters in terms of seeing what type of pictures we have. If there's a problem with the pictures, if we have the wrong pictures, we clean up those pictures. If we have different sizes, we change the sizes, and then we make sure we have the right data. All right. So if we have the right data, remember what we say, if we're using MindSpo, if we're dealing with exporting the data or processing the data, there is the MindSpo.data set, which we're going to use. So in this case, for example, where we look at the data, make sure that the data are clean, right? So we don't have what we call dirty data. So when we talk about dirty data, we talk about data with inconsistencies or data with any type of issues, right? So and then we're going to set up the hyperparameters. The hyperparameters, it means that we're going to see, okay, what will be the type of size that we are expecting the pictures to have. When we're doing a gradient descent, what type of band that we're going to take. The numbers of epoch. Epoch means that numbers of time that we're going to train the model. So we're going to train the model 5 times. So we train the first time, we see what's the loss. We train again, what's the loss? And then as we're training, the more we're training, the more accurate our model will be. So let's say, guys, as we're training the model, we said our numbers of epoch will be 1,000. So we're going to train it 1,000 times. What happens if, as we're training, we are reducing the loss? So the model is becoming more accurate. And then we get to a point where the more we train, now the loss is increasing. So if we have to stop the model at the moment where we had the lowest loss, what type of method are we going to implement? Can anybody tell us? What's the name of that method which is used in that case? Remember when we spoke about normalizers? So which normalizer will help us solve this issue? Reducing the numbers of epoch, because the more we're training, the more we are just damaging our model. Can anybody tell us? Is there anyone who think that they kind of remember, but they just forgot the name? But they know what I'm talking about. Or is there anyone who does not know what I'm talking about? So everybody knows what I'm talking about then, right? Do you guys know what I'm talking about? Or you guys cannot hear me? Can you guys hear me?
So are you talking about like 3NF, 2NF, and such?
No, I'm talking about, you see, the numbers of epoch is the number of time we're training the model. So now let's say you are training your model, you are supposed to train 100 times. But when you train 50 times, you have a very low cost, the loss. But the more now, when you get to epoch 51, 52, now your loss starts increasing. Now you realize that you don't have to train so many times. So you now have to just train it 50 times and then you leave it there. So what type of method will you use there? How is that method called? We spoke about normalizers.
Is it the dropout?
No, not dropouts, but you are close to it. It's the early stopping. You remember that term, right? The early stopping. So you stop it early. It's called early stopping. The dropout is when you drop a certain group of your neural network during training. So it's the early stopping. Okay. So now, what will happen behind this training is that after we've set all these hyperparameters, that means the numbers of time it's going to train and everything, we've set all our parameters. So what's going to happen now is that the model now will look, okay, we now have different sizes of, this is how we're going to deal with our, remember, we're dealing with pictures now. We're dealing with pictures. Can anybody tell us what algorithm will be used? Because we're dealing with classification of pictures. What neural network is going to be used? Which neural network deal with image classification?
CNN.
Yes. So we're going to use a CNN here. Do you now remember the type of layers that CNN will have? The component of CNN. Do you remember?
Pooling layer.
We have pooling layers, we have convolutional layers. So here now we're going to determine the convolutional layers. These are the convolutional layers. We have this 1, 2, 3, 4. We determine how many in each convolutional, how many layers we're going to have. In this case, they had like 18, you understand? So we put all these. So these are all the information that will be taken based on the hyperparameter that we choose. And the model is now going to train based on this. Okay, so after the model is trained, we basically going to calculate all the losses and see how the model is going to perform. So all these things can be built with your MindSpore. So basically here, for example, the loss FN cell will specify the loss function. Then you have your neural network. You have all your optimizers and the matrix. When you talk about the matrix, we talk about what we are trying to measure. Are we measuring the accuracy, or are we measuring the whatever we are measuring? That's the matrix. So, and then after, we're going to save the model, right? If we save the model is saved, and then we're going to deploy the model. So if the model is ready to be deployed, we can deploy the model. Okay, so the model can be deployed on the cloud using mind serving, or we can deploy it on the device using MindSpore Lite. Okay, so that is how it's going to work. So basically, do you remember there's a part of MindSpore which can help us convert the type of file into the proper format, which is called MindIR. Remember that. So once we have our model, we can easily see how we can transform it into a mobile app, deploy it on your mobile devices, and all those things. So that's how it's going to work. All right, guys. All right. So that's it about MindSpore. Tomorrow we're going to move to the next part of AI frameworks. All right, guys. Before we can call it a day, if you can turn on your camera for the attendance. And yeah, is there any question in the meantime when we're taking the attendance? Any question?